Welcome back to Maui Huliau Foundation's Climate Literacy Virtual Classroom. In Unit 1, we learned that the ocean is one of the most important carbon sinks. Oceans absorb about 30% of the carbon dioxide that is released in the atmosphere. But as these levels of atmospheric carbon increase from human activities such as the burning of fossil fuels, the amount of carbon dioxide absorbed by the ocean also increases. When this happens, it results in a change in the seawater's chemistry. In the second part of Ocean Impacts, we'll learn about ocean acidification and the impacts it has on marine life. Before defining ocean acidification, we need to understand the pH scale. The pH scale measures how acidic or basic a substance is. The pH scale goes from 0 to 14, with 0 being the most acidic and 14 the most basic. Have you ever tasted a lemon and puckered up? Lemons have that taste because they're acidic. Plain water is exactly in the middle, so it has a neutral pH of 7. Seawater has a pH of about 8.2, but that's changing. Most people have never heard of ocean acidification. Ocean acidification is the process by which the ocean becomes more acidic as it absorbs carbon dioxide that has been emitted into the atmosphere. We know that CO2 in the atmosphere is increasing due to human activity, like the burning of fossil fuels. So with more atmospheric CO2 in the atmosphere, oceans absorb more carbon dioxide, resulting in a decrease of pH, creating a more acidic environment. This graph shows the rate at which this is changing, and it's quite alarming. So we know that oceans are becoming more acidic. Let's take a look at the process of ocean acidification to better understand the impacts. As carbon dioxide from the atmosphere is absorbed by the ocean, it reacts with water to form carbonic acid. This causes the pH to lower, but the process doesn't stop there. Hydrogen ions released by carbonic acid bind to carbonate ions to form bicarbonate ions. So as carbonate concentrations decrease, it makes it difficult for animals that use carbonate to make their shells out of calcium carbonate. If you recall in the last presentation, what animal has a skeleton made out of calcium carbonate? If you guessed corals, you're correct. Corals are just one example of an animal that would be impacted. So let's take a closer look at these impacts. Now that we know how oceans are becoming more acidic, calcification is impacted. This is the process of making shells or calcium carbonate skeletons. The most vulnerable to an acidic environment are animals that rely on carbonate in the seawater to make their hard shells or calcifying animals. Animals such as oysters, clams, scallops, and crabs, which are all important food sources for millions of people. The pteropod is a tiny sea snail about the size of a small pea, and it's a very important part of many food webs eaten by organisms ranging in the size from tiny krill to whales. Studies have shown that shells of these animals, when exposed to acidic environments, slowly dissolve after 45 days. This can have catastrophic effects to the marine food chain. You'll learn more about pteropods in one of the activities. Many animals, like sea urchins, spend their early lives as larvae while they develop. Larvae are very small, dispersed by ocean currents, but although small, they are very impacted by acidic environments. Many of these animals will not develop properly when acidity increases. Some studies show that fish larvae lose their ability to smell and avoid predators. Skeleton-building animals like coral reefs are also being impacted as carbonate is decreasing. We talked about the importance of coral reefs, so ocean acidification can be detrimental to reefs and the animals that rely on this habitat. Even non-calcifying organisms like fish are impacted by a more acidic environment. Studies show that some fish, like clownfish, ability to detect predators is decreased in a more acidic environment. Ocean acidification can be a complex process, so after this presentation, watch the ACE ocean acidification video in the introduction folder. Let's go over the ocean acidification activities. In the first activity, we introduce acids and bases and the pH scale. Next, we will explore ocean acidification further and learn how it impacts animals with shells in a calcium carbonate skeleton. The third activity takes you through a simulation of what happens when nutrients are added to coastal shorelines. And to conclude this part, you'll take a 360-degree tour of different coral reefs around the world, from Australia to the thriving reefs in the Caribbean. Get ready to explore these beautiful reefs. Once you complete all of the activities, complete the Part 2B quiz. Check out the additional video resources in the Google Classroom.